Hi, this is Michaela Brown, and this is my presentation on arsenic. So this is just going to be a brief presentation about arsenic, its effects on people and the environment, and a couple analytical processes that are used to detect arsenic in the environment, and a couple that are used to detect arsenic in the human body. So here's a quick introduction. Arsenic is just an element from the periodic table. So it's an organic element with an atomic mass of 74.92 grams per moles, and it can be found pretty much everywhere on Earth. So it can be found in the environment, in water, air, food, and soil. This presentation, I'm mostly going to be talking about arsenic in water, specifically drinking water. Arsenic is highly toxic, so most people, when they hear the word arsenic, they're just thinking poison, death, things like that. So it has a bit of a negative connotation because of some of its properties. So here is a picture of what arsenic looks like in real life, and then a little example from the periodic table of where you can look at it, its symbol and all of that. So the symbol is AS, its mass we already said was 74.92, and it has an atomic number of 33, which means it has 33 protons. Arsenic can be used in a number of ways. It can be used for industrial processes, pharmaceuticals, feed additives, and even pesticides. So I'm going to get into a little bit of a history of arsenic. Throughout history, arsenic has come up a few different times. Hippocrates originally used it so he said, cure some diseases, and so he kind of put that out there as a common cure. So then people were just ingesting arsenic and hoping that they wouldn't die from other diseases, not knowing that it was actually poisoning them. And then we have around 1910, a German scientist named Paul Ehrlich. He invented this drug called salvarsan, and it was a drug for syphilis. It was made mostly of arsenic. So now in the early 1900s, we have people literally taking arsenic to try and cure syphilis, and of course, these people do not make it very long. It also has a common use as poison. Especially during the Middle Ages, it was very difficult to detect arsenic in the body at all. So it was very common that it would be a poison. A lot of the times it would be misdiagnosed as pneumonia, but it was actually arsenic poisoning. Arsenic in the past has been used in rat poisons, although we really don't do this anymore just because then you have dogs eating the rats and all kinds of stuff happening because it's in the rat poison. We also use it for wood preservatives, so lots of preservation for wood. It's not pure arsenic, but it's a mixture of copper and arsenate. And this is really where the bulk of arsenic is used today. About 90% of all arsenic used is going to be with this wood preservation. So that's going to help preserve the wood, keep out any nasty organisms, keep the wood from rotting. So this is going to be on things like wood that's used for building houses. There is a little bit of a concern because sometimes that treated wood is used for playground equipment or even in raised flower beds, and then that arsenic can leach into the soil and start causing problems with the soil or even leak all the way into our groundwater. So in about 2004, the EPA, the Environmental Protection Agency, pulled any arsenic treated wood that was used for residential services. So you will not see any of this treated wood in residential type things. It has also been used as pesticides, and that's going to be mainly on cotton plants. So you may see more arsenic in areas where there's a lot of cotton farming. Even where I live, which is the South Plains in Texas, there's tons of cotton. So it could be common that arsenic is going to be used as a pesticide. Worldwide, the majority of arsenic is going to be produced mainly as a byproduct from smelting of metals like copper and like lead. Here's a very cool visual for you, just some poison chemistry of white arsenic. So there's different types of arsenic. This specific one is arsenic oxide. Very small dose to kill someone. Effects could be headaches, discoloration of nails, vomiting, or a metallic taste in your mouth. Your breath might smell like garlic. You may have stomach pain. You may have hair loss, convulsions, and potentially death. So it also shows a couple of treatments, and it also shows how we can detect it. So the Marsh Test involves reaction of a sample with zinc and acid. If arsenic is present, it's converted to arsine gas. Heating arsine decomposes it, and then a silver black deposit of arsenic is formed upon cooling. Modern spectroscopic methods are now used more than this test. So now arsenic in the environment. This is going to be found in soil, in rocks, in water, and even in air. In Earth's crust, it's going to be about 5 parts per million. Generally in nature, arsenic is going to be combined or bonded with oxygen, chlorine, or sulfur. Plants and animals are also going to contain arsenic, but again, that's usually a bonded chemical, so with carbon or with hydrogen. In nature, arsenic is usually as a compound. It's not normally found in its pure form. But we can extract arsenic from Earth's crust via ores. So when we're like mining silver, we can find a lot of arsenic compounds. Those can be heated and can convert arsenic sulfide to arsenic oxide, which is kind of what we just looked at on the last slide. And then it's heated with pure carbon. The carbon reacts with the oxygen, and as a final product, we would have pure arsenic. Arsenic in drinking water is really my main point that I wanted to talk about today. So the U.S. water can contain no more than 10 parts per billion of arsenic. So arsenic or higher levels of arsenic and sometimes arsenic poisoning from drinking water is going to be more common in countries like India, Chile, China, Argentina, Mexico, the Philippines, and the United States. So a few effects on humans. We already said that it is toxic. Small doses or small amounts can really cause some not good negative effects on humans. You may have nausea, vomiting, diarrhea, and more. If you're exposed to larger amounts of arsenic, you will have worse symptoms like an abnormal heartbeat. You might have damaged blood vessels, tingling hands and feet, even going to a coma and potentially death. So a couple other abnormal symptoms could be your skin might turn red and swollen. You might develop warts. A lot of times people that have been exposed to a lot of arsenic have weird spots on their hands and feet. Most people come into contact with it from contaminated food and water. Sometimes you'll have contaminated air. If arsenic is ingested in large quantities, it's going to lead to cancers, specifically in the bladder, in the kidneys, in the skin, or the lungs. So this, again, I already said it could be ingested through contaminated water, but also potentially through seafood. So we can test for arsenic in drinking water. These tests, I'll talk about what all they're testing for in a second, but a couple of different tests that you can do to find the arsenic is chromatography, mass spectrometry, and other different testing kits like in the boxes that are posted there. So there's all different kinds of tests which are listed on the left side, and it tells you exactly what it's detecting, the detection limit, and advantages of these specific tests. So when we're removing arsenic from the water, first we have to test to see if it's there. Once we realize that it's there, we can remove it. So a couple of tests include co-precipitation. That is when iron binds to the arsenic and then it's removed. We have adsorption, where arsenic binds to aluminum or iron and then it's going to be removed that way. There's membrane filtration. That's just where arsenic is going to be filtered from the water the best that it can. Then we have ion exchange. This literally exchanges ions, and the main one that is used is chlorine. So chlorine will be replaced with arsenic in the water. There's also a potential to place certain plants in places that there's a lot of arsenic in the soil or the water. One of the plants is listed there for you. So the University of Florida actually did this study recently and found that this fern absorbs arsenic in the soil and it can help clean up waste sites. So that is something that's worth looking into in the future, is just planting more of these, and hopefully those ferns will kind of absorb the arsenic. In the human body, we can test for arsenic generally through a urine test, because arsenic is not absorbed super easily. So with a simple urine test, you'll be able to see how much arsenic you've been exposed to. So in conclusion, arsenic is something that is pretty well known but kind of has a negative connotation. It's a metalloid that is found straight from the periodic table. It's had a few different purposes throughout history, anything from a cure for diseases like syphilis to people realizing that it's toxic and using it as a poison, and it going undetected for a really long time in history. Today we're mostly using it for pesticides and a little bit for wood preservation, but now we know most of the health risks that are associated with arsenic. There's still a lot of studies going on about other specific health risks and how much arsenic can cause some of these things and how long you have to be exposed and things like that. So one of the main issues is that it's leaking into our drinking water in some places, which is going to cause some health issues, not only in humans, but in livestock, and can even affect plants. So currently we have some pretty good tests to look for the arsenic in water and arsenic poisoning in humans. So I really think moving forward, the main thing with arsenic is just to figure out how to have less of it in our drinking water so that we won't have some of these health issues. My references are listed there for you, and that's it. Thank you.